various people have started asking me, what do we do? Well, we work with a certain type of material called a semiconductor. Now, as you know, there are metals in the world, and metals are very good at conducting heat and also very good at conducting electricity. Then there are insulators in the world. Insulators like rubbers, plastics and ceramics, yes, even this little duck, are very bad at conducting electricity and also very bad at conducting heat, so we employ them as insulation. And then there are semiconductors, which sit somewhere in the middle and can be changed between behaving like a metal under some conditions or an insulator under other conditions. And this gives us the freedom to play around with this interesting material. And the thing is, with semiconductors, we can make LED lights, we can make lasers for telecommunications, we can make microprocessors for computers and mobile phones, and we can make power electronics. In fact, everything on this desk is powered and made from semiconductors. Well, not the book, or the pen, or the pencil, but you get the picture. They're very useful things. Now, semiconductors are actually grown. I mean, vegetables are grown and fruit is grown by people like him and him, but semiconductors are grown but not like fruit and not like vegetables and not by people like him and him. Semiconductors are more grown like gems. And you might know that gems can be grown naturally in the earth with lots of pressure and heat, or in a lab. And semiconductors, like the ones we use, are not grown naturally. They're created in a lab. And actually, semiconductors are rather similar to gemstones, but we only pick one direction to grow. So rather than being three-dimensional, like a gemstone, they are two-dimensional and grown on a disc, which you can imagine as a single facet or a single face of a gemstone. So we grow one-directional gems and turn them into semiconductor devices. And we do that in equipment like these, which are very difficult to operate and very complex. So one of the things we do is we take this very difficult to do thing and we make it simple by providing a teaching course to explain how to operate these complicated equipment to create the semiconductors that you want. And after you know how to operate it, no one wants to operate it manually because it's very difficult and time consuming. So we create automation in the terms of software. And when you look at one of these growth equipments, there's software everywhere. There's software over here, software there, software over here, more software in there, software, so much software. And the fact is, all this software does not talk to any other software. And that makes it very difficult to control the whole system holistically. So we created a modular software ecosystem where we control and create all the individual blocks of software, and we make sure that they all interact and integrate into create a complete whole that we call a lab operating system. And once you have all these parts talking to each other, you can then employ AI to control these systems so human beings waste less time and can start thinking about bigger things. And what does this mean for our semiconductor devices? Well, this means that we will be able to create with AI higher quality materials with less waste, which is great for the planet, more uptime of this difficult to operate equipment, higher throughput, and even discover new materials with great properties for the future of our species. So this is what we do. We at Bizmuth MBE create software and training courses for the future of the semiconductor industry. And if that sounds something like you're interested in, then DM me to learn more.